Definition of obesity. Obesity is a complex and chronic disease defined by excessive fat deposit that accumulate and lead to many complications of health. Studies have shown that overweight and obesity increase the risk of chronic health conditions such as type 2 diabetes mellitus and cardiovascular disease. Next, for classification BMI for obesity, according to WHO, it is stated that BMI for obesity person it is greater than or equal to 30, while according to Asian, it is stated that their BMI will be more than 27.5 for obese one. There are many causes of obesity, and one of them is food, which is the person they tend to take diet that have high intake of fats, and the other is due to physical inactivity.
The FTO gene is associated with obesity, primarily influencing eating behaviors such as food consumption and also selection, rather than metabolism. This may lead to a preference for energy-dense and high-fat foods. Next, the MC4R gene plays a significant role in regulating weight and appetite, with variants linked to childhood obesity. Mutations often result in severe obesity phenotypes and are inherited in a codominant manner. These findings emphasize the importance of genetic research across population.
So for last but not least is the APOA2 gene or apolipoprotein gene that it plays a crucial role in triglyceride catabolism by regulating lipoprotein lipase activity and at least in part here through HDL protein modulation.
Nutrigenomics was first introduced by Garrett in the early 20th century. It explores how genetic variations affect our ability to process nutrients. For example, conditions like phenylketonuria or PKU or lactose intolerance highlight how certain gene mutations can impact our diet choices. Fast forward to the 1990s, the Human Genome Project mapped our DNA, revealing connections between diet, genes, and diseases. By 2007, researchers found multiple links between nutrients, gene expression, and also health. Advancements like microarray analysis and next-generation sequencing now allow us to understand how specific nutrients influence our genes. Companies like 23andMe offer personalized diet plans based on genetic indicators, tailoring nutrition to individual needs.
Nutrigenomics studies how food influences gene expression and how genes affect body's response to food. It explores how nutrients activate, inhibit, or regulate genes impacting health and disease risks like cancer and heart condition. By identifying how specific nutrients affect genes, Nutrigenomics enables personalized nutrition for disease and prevention and better health. There are three key differences between nutrigenomics and nutrigenetics. The first is the focus area. Nutrigenomics study how diet influences gene expression, while nutrigenetics examine how genetic variation affect responses to nutrients. The second difference is their objective. Nutrigenomics aims to uncover how diet impacts health to create general dietary guidelines, while nutrigenetics focus on creating personalized nutrition plans based on individual genetic makeup. Lastly, the research scope. Nutrigenomics explore how nutrients regulate gene activity, while nutrigenetics identify genetic factors that influence nutrient absorption, metabolism, and utilization.
Understanding how genetic variations affect nutrient absorption, metabolism, and utilization, dietitians and nutritionists can prevent and manage chronic disease. Nutrigenomics enables them to recommend strategies that can mitigate risks associated with specific genetic profiles, such as obesity prevention, by identifying genetic variations. Understanding how genetic variations affect nutrient absorption, metabolism, and utilization. As the science behind nutrigenomics continues to evolve, dietitians and nutritionists will need to stay informed through ongoing education and research. And this includes understanding how to interpret genetic tests and integrate this information with traditional dietary assessments. Nutrigenomics allows dietitians and nutritionists to offer personalized dietary advice based on an individual's unique genetic makeup. By analyzing genetic predispositions to certain health conditions such as obesity, cardiovascular disease, and diabetes, professionals can recommend specific diets that may better support a person's health. And genetic tests can determine how someone metabolizes certain nutrients like fats, sugars, and vitamins, helping professionals tailor diet plans to improve health outcomes.
For the benefits of nutrigenomics, first, nutrigenomics can tailor diet and nutrient recommendations based on individuals' genetic profiles, for example, factors like nutrient intolerance and specific health needs. For the benefits of nutrigenomics, First, Nutrigenomics can tailor diet and nutrient recommendations based on individual. Second, Nutrigenomics can improve disease prevention by identifying genetic predisposition to certain diseases like cancer and obesity and how diet can affect their development. Second, Nutrigenomics can improve disease prevention by identifying genetic predisposition to certain diseases like cancer and obesity and how diet. And third, Nutrigenomics can improve mental health by helping individuals understand how genetic composition influence emotion.
There are common misleading claims about nutrigenomics. First, some claim DNA testing can provide a perfect diet or guarantees optimal health. In reality, while it offers guidance, factors like lifestyle, environment, and gut microbiota also influence health outcome. Second, it's misleading to say nutrigenomics can prevent all disease. It helps identify genetic predisposition and optimize diet, but cannot eliminate disease risk entirely. Lastly, the idea that genetic tests alone can solve health problems is inaccurate. These tests provide a partial information and must be combined with a full health assessment for effective results.
Satiety signal and increasing the risk of obesity. Managing MC4R-related obesity involves a diet rich in dietary fiber to enhance satiety and omega-3 fatty acid to improve hormonal signaling, reducing inflammation and support metabolic health. The FTO gene is associated with the obesity through its influence on appetite, increased calorie intake, and preference for energy-dense food, which increase chances to weight gain. Nutritional strategy to manage FTO-related obesity include high-protein diets with enhanced satiety but affecting adiposity and appetite-regulating gut peptide, and the diet rich in fruit, vegetable, and whole grain, which is effective in reducing body fat mass and also preventing obesity.
In preventing obesity, Nutrigenomics can play a role by tailoring dietary recommendations to an individual's genetic profile. For example, first, improving appetite and satiety. Genes like LEP and GHRL control hunger and fullness. Eating foods high in protein, fiber, and healthy fat can help manage this hormone and prevent obesity. Next, improving insulin sensitivity. The TCF7L2 gene affects insulin function and inflammation, which are linked to obesity and diabetes. Eating omega-3 fats and food with polyphenols can help improve insulin sensitivity and reduce inflammation. And third, managing eating habits and circadian rhythm. The clock gene affects cravings and eating patterns. Eating food that keep blood sugar stable like whole grain and vegetable can help reduce craving. And meanwhile, food rich in melatonin can support metabolism and fat burning.
In Malaysia, the establishment of Nutrigenetic and Nutrigenomic Research Unit at Utah is a significant step toward tackling malnutrition and advancing precision nutrition. Collaboration with global institutions are helping raise awareness, but more education and evidence are needed for greater acceptance. Globally, Nutrigenomics is recognized for its potential to manage chronic diseases like obesity and diabetes. However, privacy concerns and ethical challenges remain barriers. Clear regulation and public education are essential to boost trust and drive adoption.
The success of Nutrigenomics in Malaysia offers hope for tackling the country's high obesity rate, currently the highest among adults in Southeast Asia. Raising awareness, training healthcare professionals, promoting personalized nutrition, and fostering collaboration among government, research, and private sector are the key steps toward integrating Nutrigenomics into healthcare and reducing obesity and diet-related disease.